FTP is the file transfer protocol, and it provides a standardized set of instructions for computers to upload and download files from a shared device. What does this mean? Basically, if you want your data to be available on the internet, but you don't want to keep your computer on all the time for people to come and get that data, you can use FTP to store your data on a shared device, and then other people can access that device to grab files. So that's the gist of it. And this protocol uses the server client model. And the idea is that the server will store all of the data, will keep all the information, and then clients will be able to upload and download files to and from that server. So you have all of your data centralized. A client can say, I want to upload a new file, I want to download a new file, I want to delete a file, I want to move a file around. The server is the one that's responsible for storing all that data, and the clients can just come and go as they please. If this sounds a little bit familiar, you probably have used services such as Google Drive, OneDrive, Dropbox, Box. These are all basically successors of FTP. FTP is kind of the precursor. Bigger, it was a much bigger thing in the 80s and 90s. Still, it's used by a lot of people as a cost-saving measure. If they have like a lot of files they want to share it, and they don't want to pay for those other services, you could use an FTP server to go and do that. But you've probably used these more modern versions rather than the older one. Another cool thing is that because FTP is so old, they didn't get too complicated with the way that it's designed. And so FTP is actually a text-based protocol. And that means that you should be able to read the traffic, the FTP traffic, without any special tools. You can actually read it as text, which is nice. And the idea is that when the computers are communicating with each other, the client will send word commands. Like they're actually like letters that form a word, and that word is command to tell the server to do something. And the server, when it executes that command, it will respond with a numeric status code so that the client knows what happened. And you can see here kind of an example of this. We have the client on the left side sending a request. It's sending user, my username. So that's basically trying to log into the FTP server using this username. The server responds with a status code 331. It says password is required. The client will come back and say, okay, here's my password. It's my password. And then the server will say, hey, status code 230, you're logged in. That's the basic gist of this. Now, there's a lot of additional information that might be included with these messages, but I'm just giving you the high-level summaries to make it easy for you to understand. Everything that we're going to do today in today's episode is going to be about trying to understand how the computers interact with each other, which means that we're actually going to go in depth into understanding, like, how do I find out what the user command means? How do I find out what status code 331 means? You'll be able to learn this so that if you encounter different status codes or different commands, you'll be able to figure out how to understand what it means. Today, we're going to go through this great example over here. In this example, we have the text output of a communication between a server and a client. And in this case, the server is red, the red text here, and the client is blue, this blue text. And what happens is as soon as the client connects to the server actually initiates a communication. That's what this the first three red lines are. That's the server immediately going and letting the client know this information. And so let's take this step by step. How do you read it? Very, very simple. Google search. So you can just go on Google, you can type in list of FTP commands if you have no idea what they are. Funnily enough, there's a whole Wikipedia article that tells you exactly what the FTP commands are. And you can read up on those and see every single one. Here's what that looks like. And so we're going to reference this today as we go through these examples. You also might want a list of FTP status codes. You can Google that as well, and you can get another list of FTP status codes. And that's the very, very, like, that's 90% of the battle right here, right? Like just these two Google searches will give you basically everything you need to know. And so here's a list of FTP server return codes. And let's just dive into it now, right? So I showed you on this slide over here, where is it? The list of the return codes on Wikipedia. What I'm going to do is I'm going to look, and I can see here at the beginning of every response we get from the server is the number 220. And if you actually go to the Wikipedia page on your own and you search it up, you can search for 220 on the Wikipedia article, and you can see that the status code 220 means service ready for a new user. I think that makes enough sense, right? If you look at the other text along with the status code, it looks like the server is providing additional information to provide some context to the client. So we're getting information like what type of server is it? It looks like it's a file server, a FileZilla server, and you get a version number and a beta. There's even information about the author, and there's also a link to the website. So when the client connects, it gets all this information. Let's move on to the next step then. The client now sends a command. It sends the user command. And you can see here that it's user space user1. And if we go onto Wikipedia, we look at the table, it says the user command is the authentication username. And I think you could probably assume that what immediately follows is probably that username itself. You probably don't need to read additional documentation to realize that after the user command is the actual username that we're trying to log in with. Okay, so next the server responds, and it has a 331 status code. Again, go into the Wikipedia article, Control F, 331, and it says username is okay, needs a password. All right, great. The client now sends a new command. It's the pass command. The pass command is the authentication password. And in this case, you can see the password here is Metropolis. So this is what we're seeing right now is someone attempting to log into the server. And when we move on to the next step, you can see status 230 logged on. So at this point, it looks like that password was successful, right? We typed in our username, we typed in our password, we get a status 230. 230 means users logged in, proceed. We're all good right now. Cool, that makes sense. Okay, let's move on to that next question, the next step. We see a port command, and when you read the description here, it says specifies an address and port to which the server should connect. Okay, I thought we were already connected. Like, what does that mean, right? Like, if we're already saying this information, should we be already connected? Why is there a separate address and port? So this is a good time to do a little bit more Googling. And what we can see here is not only do we get the port command, but we get this series of numbers separated by commas. So we need to figure out what that's about as well. So let's do a Google search. I did a Google search for just FTP port command. And the top result here, port FTP command from SolarWinds. It's an article that describes it. Let's go check it out. And I got some highlights from this article. What I can see is that this port command initiates a data connection required to transfer data, such as a directory listing or some files. So it looks and it appears like, and you can definitely do more research about this, but I already have some background knowledge, so I can tell you that basically the commands that you send to and from the FTP server happen on a separate connection from the actual transfer of the data, from the actual transfer of the files. And I think that's mainly for efficiency purposes and for usability purposes. So if you want to transfer any data, you need to establish a new connection. So this port command is providing the information required for a new connection to be established. Actually, I'm remembering now there is a specific reason for opening up a separate channel and having to provide this information. The server is only listening on a single port, and if you Google this, you can find out that FTP servers are typically on, I'm Googling it right now, FTP port. The FTP port is port 21. So if there are multiple people connected to this FTP server, there needs to be separate connections to transfer all those separate files. Because if you are transferring a file on the same connection that you're sending the commands, then all that data is going to clog up your command terminal, and you won't be able to like execute new commands concurrently. And so if you open up a separate channel, it allows for that data to be transferred without messing up your command session. So we can see here with the port command that the information that's being included is information on the address and port that the server is going to use in order to connect back to the client. So the server, when it sends the data, it's going to use this information and send it to the address and port that is being specified with the port command. And we can see that the structure of the port command is H1, H2, H3, H4, P1, P2. And then it breaks it down even further. It says H1 through H4 are the parts of the IP address, and P1 and P2 are used to calculate the port number. And they have this calculation that the port number is P1 times 256 plus P2. I have a pretty good gut feeling that the reason why there's this math involved in calculating the port number is because there was a limitation in how large the number could be. And that's probably why they had to split up the number with all these different commas. I think each number could only be up to 256, which is why we're splitting it out, but having to do this math. If each number in the parentheses here can only be a value between 0 and 255, then there's no way that you can fit a very large number in there. And that's why you have this math. All right, so let's actually see if we can extract that information. Here is the data from the port command. You can see it's 129, 2, 205, 242, 207, 243. So the first four numbers are the IP address. And it's just that. It's those numbers with dots in between them. And with the port number, we're going to take the 207, multiply it by 256, and then we're going to add the 243, and we get a number which is 53,235. This seems like a very large number. Typically, when you see port numbers, you're probably used to much smaller port numbers. The port number for FTP was port 21. That's a much smaller number. The reason why this port number is so large is because the smaller port numbers require admin permissions for you to be able to run a program that can listen to data on that port. And because the user, the client, may not be an admin, you can't use a low port number when connecting to the client. So the client actually has to listen to a very large port number called an ephemeral port, which does not require admin permissions, and those are higher port numbers. All right, so we've dissected what port means. It appears that we're going to be establishing a separate channel for sending some data, and we get a confirmation here now from the server, status code 200. This means that the action is successful and we're good to go. And the client now makes another request. It's the list command, and it says returns the information of a file or directory if specified, or the information of the current working directory is returned. So right now, if you're familiar with the command line, this is the equivalent of running the dir command, dir, on the Windows terminal, or the equivalent of running the ls command on Linux. We're really just trying to see what files are in the folder that we're in by default after we've logged into the FTP server. And you can see that FTP server now gives a status code 150. It says status OK, about to open data connection. That's probably a reference to that port command from earlier. It's going to use the information from that port command to actually open this data connection. And then we now move on to the last one here, 226. This means that the data connection has been closed. The file action was successful, for example, a file transfer, and it's done. But you can see here that we don't actually see the listing of the data, right? It says that the action was successful, but you're wondering, where is the data? Where are the actual files that are listed? Because the port command opened a separate session, we don't actually see it in this session. Um, and so we'll have to dive into that in the demo because I don't want to make it too confusing in the slides here. But what we've seen basically is how to walk through this FTP traffic, understand the communication that's happening here. There's a couple of more commands that happen, and I'll leave that as an exercise to the user to figure out what those commands are doing. And you can, use the knowledge that I've given you of just using Wikipedia to find out what those commands mean. But I think at this point, it probably makes sense to go more to demos. So you can actually see, okay, how do I actually look at this traffic in a packet capture now that I know how to read the information? And then we're going to go into how can you create your own test environment, right? How can you actually go and try this out in your own lab? So we're going to go from slides to going into the how do I look at data that has been given to me, to how can I create data and play around with it so I can create my own scenarios. All right. So as a recap, before we move on, FTP servers are storing and managing files. FTP clients are connecting to those servers and they're uploading and downloading files or interacting with them in other ways. The traffic is text-based, so you can read it, by humans. Humans can read it very easily as long as you understand what those commands mean and what the status codes mean. And there's plenty of online resources to help you understand what those status codes mean. So use them, right? Make sure you go and Google around and search up. If you don't understand what the explanation is that you got from Wikipedia, you can do more research online. Those tools are at your disposal. There's no way that I can cover the extent of everything you can do in FTP in this short session here. And so you really need to be able to have the tools to go online and you have to be able to go online and do your own research and learn these new things on the fly. And that's what I'm trying to teach you here with all this Wikipedia stuff and all this Googling stuff, right? All right, cool. So let's switch over into our Kali Linux machine. So I've got Kali Linux running over here. And this is a great time as well if any of you have any... Oh crap, I changed my password. Let me see if I remember it. All right, I remember my password. Cool. If any of you have any questions, please ask them now, and I'll answer them as we go through this demo here. All right, so if you are currently if you're currently in some sort of Cyber Skyline event or exercise, you should have access to the gym. And there is a challenge in the network traffic analysis section in the gym called FTP. If you go to that, you can download this packet capture, which is in that challenge. And we're actually going to go look at that packet capture. Part of this packet capture was in the slides today, and we're going to go investigate it and try to make sense of what's going on. So right now, we've opened up the packet capture in Wireshark. If you don't have Wireshark, I highly recommend that you download and use it. In the gym, there is CloudShark, which is a version, it's a packet capture reader, which is similar to Wireshark, but it's not as feature complete. And so it might be a little bit easier to do what we're doing today with Wireshark directly on your computer. Now, if you don't even know what's going on right now, basically the data that gets transferred to and from different computers and network devices can be stored in a file called a packet capture, a PCAP. And you can use CloudShark or Wireshark to open this. And so if you've got CloudShark in the browser, or if you've got Wireshark in Kali Linux or installed on your computer, you can open up this packet capture and analyze it and start seeing some of those things that we saw in the slides. And when we open it, what we're seeing here is a list of packets. A packet is just a snippet of data that is being sent to and from different devices. And so you can see here that they're numbered. From the very beginning, we've got all of these packets. I don't know how far it goes. Let me see if I can find the scroll wheel on this. get to the end. Okay, it looked like there's about 100 packets in this packet capture. 97. Okay, cool. So what I'm gonna do in cloud in Wireshark is right click on this packet, packet number one, and I'm going to go to follow and then TCP stream. Now the equivalent of doing this in CloudShark is if you click on packet number one, you go to analysis tools, you can do follow stream here. This will give you the same display that we get in Wireshark, right? So it's the same text. So it's equivalent. That's how you do it in CloudShark. What this is doing is it's grouping multiple packets of data together so you can read it as one continuous piece of information. If we don't have the TCP stream, what we have to do is read each individual packet separately. So I can click on a packet here. I can see here's similar to what we saw on the slides. Status code 200, FileZilla server, written by this author on this website. We go to this next packet. It says user, here's their username. So like this is all of the data that we were looking at in the slides. It's available here, but you can see this isn't exactly the nicest way to read this. The text is scrunched, it's not formatted. There's some data which is not human readable, and it shows up as these little dots or some random characters like this. And that's why you want to do follow TCP stream, because when you do follow TCP stream, it will clear out a lot of the data that you're not interested in and only show you specifically the traffic that is being sent to and from with this protocol. This normal view here, when you don't do the follow TCP stream, will show you a lot of the like extra information which is necessary to facilitate the delivery of the packet. It's basically the to and from information and stuff like that. When you send like a letter, there's similar data that is stored in a packet. And so we want to skip all of that and we want to go straight to follow TCP stream and just look at this information. All right, so this is slightly different. This is actually shorter than what we saw in those slides. And what we can see here is this attempted login with user one. It says password required. There's a password Cyber Skyline. It says the password is incorrect. And then there's a quit command and it says goodbye. So this looks like a bad login attempt. They tried a username, they tried a password, it didn't work, they disconnected. All right. So let's back it up. We can see that this TCP stream went from 1 to 7. And so if I clear out our filter and I go to packet 8, let's see what that session looked like. And one thing to note is when we're doing this TCP stream, we are separating the data into sessions. So when someone logs into the FTP server or they connect to the FTP server, they do whatever, they disconnect, that's one session. So we can switch between sessions by using this method. I'm going to follow the next TCP stream. And in this case, this is specifically what we saw with the slides. We can see here, user one is a login. The password is Metropolis. Here are all the ports. Port command successful. There's the list. Okay, so here's everything. So the first thing that I want to do, because we didn't get a chance to do this in the slides, is verify when it did this directory listing, did it actually use the information from our slides? Let's take a look at that. So if I close this out and I get out of the TCP stream, I can read this info column and I can see this information. You can see the port command successful, list, opening data channel. And then this is interesting here. Well, all the other data that we're looking at, the protocol is FTP. There's a new packet in here that says the protocol is FTP data. And it happens to be that this packet is what was sent as a result of this list command opening up a new channel to communicate with the client and send the directory listing. And so if I actually come here and I do the follow TCP stream, I can see the file listing that was sent back to the client. This was not available in a previous TCP stream because that TCP stream was a single session, and when the data was sent for this directory listing, a new session was created to send this data. And so it wasn't in our second session. It was actually in a new session. And that's why we had to go and analyze it this way and try to find it. And so we can see here that there's some information. There's bank.cap, there's ftp.pcap, launchcodes.jpg, there's bedroom, Lincoln bedroom.cap, security codes.txt. So these are all of the files that are listed on this FTP server. Let's go back to packet number 8, do our follow TCP stream to see what happens next. So we saw that directory listing, we saw what was there. And actually, before I do that, let's verify the port information, right? So here's the port information being sent, and then here's the FTP data. And let me cut back to what this information was supposed to be. So it's supposed to be, this is the IP address it's supposed to be, and here is the port that it's supposed to be. So the IP is supposed to end in 242, and the port is supposed to be 53235. All right, let's go check it again. So if I go over here and I try to look at all this additional data that's within Wireshark, I can actually get some additional information, such as the source and destination address. And so the destination address indeed ends in 242. It's the IP address that we saw before. And the destination port over here, 53235. That's the number of the port that we saw previously. So this is indeed the information that we were given in that port command. So this all makes sense. This all lines up. So that's cool. Let's move on now for the rest of that FTP session and see what else is there. Okay, so what happens after the file transfer? You can see delete bank.cap or delbank.cap. I know that's the delete command. Go and Google it if you don't believe me. Then we get a status code 250, file deleted successfully. There's another port command, so it looks like we are creating a new data channel to send some file. Port command successful, STOR. So this is the store command. This actually allows you to upload a file. And in this case, we are uploading compcodes.zip. And you can see here, the server responds, opening data channel to upload compcodes.zip. We successfully transfer it. And then the client disconnects. It does a quit, and then the server says goodbye, and then the session is closed. So what has happened here is that this compcodes.zip was uploaded. Now you're probably wanting to see that compcodes.zip. So I got rid of my filters here, and you can see here FTP data. So this is the file transfer, and you can see that it is associated with the command store compcodes.zip. So if I go here, I can do follow TCP stream, and we see a lot of random data. This is because the file that was transferred is a zip file. It's not like a text file. So this is actually just binary data that we're trying to read as ASCII, which is not ideal. What you could do actually is come in here and try to export this data and treat it as a zip file and open it. So if I come in here and I say show data as, let's just do raw. So this is like, I think this is displaying the data in hexadecimal. This is what the actual binary looks like. I am going to try to see if I can just save this as is and then view it as a file. And so I just saved it. Let's go to my downloads folder. I've got compcodes.zip. Hey, look at that. We've got all of these files in this zip we've got everything in the zip file, right? In the zip archive. So if I come in here and I extract here, it looks like there's all these different files. I don't know what all of this is, but we were able to look at a packet capture, see a file get transferred via FTP, and then get a copy of that file for ourselves. And that's just by using these different tools within Wireshark. We got lucky that with this TCP stream on the FTP data, when we exported it, it didn't have any additional like metadata or like padding or anything. It actually was like a direct one-to-one of the file, and so we were able to extract it and analyze it like just as is. With other protocols, you might have to look into it because there could be some padding or some metadata or what have you that could mess with this. But another cool tool that Wireshark has is the ability for you to export this data without like trying to like click around and find the specific packet that has that data. That's what we ended up having to do, right? Like we specifically had to go and find the FTP data for the compcodes.zip and right click on it and then follow TCP stream and then export that data, right? We had to follow all of those steps. You actually don't have to do all of that. Wireshark has an auto export tool. If you go to file and then you go to export objects, you have an option. Oh, actually, maybe you can't do it here. Ah, that's a shame. That's my bad. I thought you could do it FTP. I think you can only do it with HTTP or TFTP. I don't know why they don't have an option for FTP. But if you're analyzing HTTP traffic, web traffic, you can click this button. It'll auto export all that data. But I guess for Wireshark, they don't have that tool in there. I thought it was there before, but I guess not. So you are actually required to go and do this thing and view the FTP stream and do the save as to export it and get the file that way. But that's cool that we're able to actually extract the file directly from the the FTP traffic. All right, so I'm gonna pause here for a little bit and get myself set up for the next stage where I actually set up an FTP server to play with. If anyone's got any questions, now is a great time to ask. I'm going to to look and see what we've got here. We've got a question from Brianna. Will the session be available to rewatch? Yes, it will be here on Crowdcast, although I think the version on YouTube will be a little bit better because that will be edited to get rid of the audio from the audio issues from before. All right, yeah, please ask if you have any questions about FTP, any questions about how the protocol works, or how to use Wireshark. We're going to be using a little bit more Wireshark later after we set up our FTP server. So um, let's let's set up our FTP server. If you are on Kali Linux, you have the great ability to be able to install an FTP server called VSFTPD, and it's a very, very simple tool to install onto your computer and use as an experiment. One thing I would recommend before you play around with this, if you're using VMware or VirtualBox, you have the ability to go and take a snapshot. So you can come to VM snapshot and you can take a snapshot. This is helpful in case you screw up and you want to go back. Take a snapshot before you start messing around. I did it before this episode. You can see that my snapshot is in here from earlier today. I would highly recommend it. So take a snapshot first. Make sure you have a safe snapshot to go back to when you inevitably want to undo what you did. If you mess up, you'll trust me. You'll save so much headache if you're able to do that. All right. So with Kali Linux, we are going to install VSFTP, VSFTPD. So the command I just wrote over there, it's sudo apt-get install VSFTPD. I have to type in my password. And this should hopefully install very quickly. It downloaded and installed. And what I'm going to do is I'm just going to run vs ftpd. I believe this will run it from the directory that I'm currently in. So in this directory, we have this wordlist.txt. If I print that out, super secret password, cool. So let's start our vs ftpd server. I just type in vs ftpd. Apparently I forgot to run it as root, so I'll run it as root. And now I've got my vs ftpd server going on right now. Okay, so let's take a break and remind ourselves what's happening. So an FTP server is storing files that I can, as the client, connect to and upload or download additional files, and I can see what's there on the server. What is happening when I start this vs FTPD server is that it is making all of my files in my home directory available to any client that connects to this server. And so what I'm going to do is I'm going to open a second tab and I'm going to connect to myself and I'm going to try to access my files. So I will type in, actually, let me go actually to my downloads folder first. So I'm in my downloads folder. I've got my comp codes in here from earlier, and I'm going to use FTP and connect to localhost because I'm running the FTP server on the same computer. This is just for the purposes of this this recording. If you want to set these up on two separate computers, the same same process works. It works the same way. If you have like a computer network, you want to put something up on the internet, all of that will still work too. So I'm doing it on localhost just because it's easier for me to do it that way, but this will work just the same if you're doing it on a remote device. You just need to know the IP address of that device and make sure that there's no like firewall or anything blocking that connection. So I connect to localhost, it's asking me to log in. So I will log in as Callie, and my password is my password. Well, we'll see what my password is later. But you can see I've logged in right now. I can do an ls, and here is everything in my home directory. Cool. So let's log out and do a packet capture. Let's actually see what this data will look like. So I'm going to come over here and I'm going to open up Wireshark. And we're going to start a new capture. If you've never started a new capture before in Wireshark, you can press this little gear icon and we'll let you listen to an interface on your computer and capture any traffic. And so because we're using localhost, we're going to listen to the loop back, and I'm going to hit start. And then from here, if I connect to the FTP server, you can see immediately all of that traffic, all of that data shows up in Wireshark. And if I come over here, I do follow TCP stream. You can see there's the status code 200 vs FTPD. So the server is greeting me, saying hello. And actually, you can see that's exactly what it says in my terminal, right? So that data is what I get in Wireshark. It's also what I get in my terminal when I connect with the command line. And now it's asking me for my username. My username is Callie. I come over here in Wireshark. You can see if I do follow TCP stream, user Callie 331, please specify the password. 331, please specify the password. All right, I'm going to type in the password. And I've logged in successfully. And if we go back to Wireshark and I follow my TCP stream again, you can see here, password, my password, login successful. Cool. All right, let's go and download a file. If you have FTP, the command line up here, you can type in the help command and it'll tell you all the different commands that you have at your disposal. I think you can also go and search for a list of these online. I happen to know that the command that we're interested in today is mget. This will go and download a file from the FTP server. So I'm going to use the ls command here, and I can see all of my files. I want to get my wordlist.txt. So I'm going to do mget wordlist.txt. And then it's asking for confirmation. I put in Y, I hit enter. The Y stands for yes. As you can see, command successful, opening binary mode, connection, transfer complete, and it downloaded very quickly because it's not even going over the internet. It's just going, whoops, cancel. It's just going on my computer. So follow TCP stream. You can see here, there's the list command to see what was listed there. And then you can see here that retar wordlist.txt. If I go onto Google, FTP commands, Wikipedia, and I search for RETR, that means retrieve a copy of the file. All right, so that makes sense. So one thing to keep in mind as well, though, I typed in the command mget. That is the human command that you type in to the command line. It turns out that the command in the FTP protocol, when the computers are talking to each other, is a different command. So they use retar, but I typed in mget. That's just something to keep in mind, is that they're not the same, right? You can use a different set of commands to talk to your, when you type on the keyboard to talk to your client, and your client will use a different set of commands to talk to the server. So just keep that in mind. Don't let that confuse you. They're different commands. All right, cool. But this now means that that we have, hopefully, in our downloads folder, a wordlist.txt. So I'm going to exit. I'm going to type in the exit command. I'm going to do an ls, and I can see there's now a wordlist.txt in here. And if I print out this wordlist.txt and I go to my desktop or my home directory and I print out the wordlist.txt in my home directory, they're the same. So we successfully downloaded a file from an FTP server. Now, they happen to be on the same computer, so there wasn't a whole lot of utility there, but it's just an experiment, right? It's a test. You can go and set up a separate server and remotely connect to it and download a file that way. It'll work just the same. And we captured all of that data in Wireshark, and I can stop my recording now, and I can see exactly what happened. I can see here that here's the wordlist.txt. Here's the retar wordlist.txt, transfer complete, goodbye. Okay, so in between requesting the file and transfer complete must be the file itself. And you can see here, this must be the data for the file itself. If I do follow TCP stream, oops. Did I not capture it? I must have filtered it out by accident. Okay, retar wordlist.txt. This FTP data, that's the data we're looking for. Follow the stream, and there's super secret password. All right, so that is how you analyze FTP traffic, and that's how you can set up your own test environment to analyze your own FTP traffic, right? So if you're at home right now, you want to figure out how the heck do I play with the different FTP commands and see what that looks like in Wireshark, go and install VS-FTPD. I definitely recommend you taking a snapshot of your virtual machine before you do that. And then you can go online, you can look up all the different FTP commands. All I did was I downloaded a file in this demo. You could go in and you can move a file, you can rename a file, you can upload a file. I think there were like way more commands there. Way more than I thought made sense. But apparently, like, look at all these different commands. Rename, trace. There's a lot of things out there. You can go and try them all. So definitely try that out. And if you have any questions, now is a great time to ask, right? So ask away. I'm going to start looking through those now and answering all of your questions. What is the information in the columns in the FTP directory listing? That's a great question. So if you ever have run the ls-al command in Linux, it should look very familiar. So I'll just do this, ls-al. It looks very familiar, right? These are indicating some metadata about each file on here. So this leftmost column is storing the information about permissions, read, write, and execute permissions. So who has access to these files? I did a video on Linux earlier. You can go check that out, which kind of tells you how to read this information, but this is storing the permissions for the file. I don't know what this second one does. I think it might indicate file, it might indicate type. I don't know. I'm not sure. I'm not going to answer this one. That's something to probably look up. This number here, I'm fairly certain, indicates who, like the ID of the individual and the group that owns that folder or file. This here is indicating the file size of that file. So folders by default, they're actually 4K. And then the actual files themselves, you can see this is 66 bytes. The wordlist.txt was 21 bytes. And then you've got the, this is a timestamp when it was last modified, and here's the file name itself. All right. Well, it does not look like people have got very many questions. Definitely, if you've got any questions after the fact, please ask us on the YouTube video. You can always leave questions in the comments. We'll go around and follow up with people in the comments and help them out. But thank you for joining me today. It's been great having you here. And don't forget, if you haven't already, make sure to sign up for the National Cyber League. We've got registration that just started on Monday. If you want to practice around with some packet captures yourself, if you sign up for NCL, you can go to the gym, and the gym will have a packet capture for you to play around with right away. So that's a great way to get started. And you can come back to this video as reference. We'll re-upload it, and you can come and view it. And before you leave today, fill out our poll. We want to know what topics you want us to cover in the future. So I put up three different topics for right now, but if people have got any ideas for topics that they want us to cover that aren't in this poll, please ask us to cover those in the chat. We will come back and read the chat and make additional videos to help you learn about cybersecurity. All right. So thank you once again for joining us today. Make sure to sign up for NCL if you haven't already. We love hosting these for you, and keep learning, and have a great rest of your day. Take care.